Hi guys, welcome to my channel. So I'm going to do a continuation of the breast cancer prediction using AI and machine learning. So what we shall be talking about today is a problem statement, the data sets that will be used, the factors considered when choosing those data sets, the important features in the data set, the Bayesian theorem, the naive bias, the Bayesian network, and the differences between them. Yes. So we are starting with the introduction of the part. So what is breast cancer? Breast cancer is the most common cancer amongst women in the world. It accounts for 25% of all cancer cases and it affected over 2.1 million women in 2021 alone. It starts when the cell in the breast begins to grow out of control. These cells usually form tumors that can be seen via x-rays or felt as lumps in the breasts. So for instance, you can see some of the signs are here. So we are continuing. Now the data set that will be used, the data set is got from Cargo. I've provided the link down below. So the database in this data set, we have the ID, the diagnosis, which is M, which stands for malignant, and the B, which is the benign. The data set tries to specify the cells into benign, which is non-cancerous cells, and malignant, which is the cancerous cells. So where there is M, that indicates cancer cells, and for B means cancer-free. So if we think about this, it's more like M or B. So it's classification problem. We use classification algorithm, and for this problem, we shall use the SVM, which is the support vector machine, and the KNN, which is the nearest neighbor. For the SVM, will actually help us find a linear separation between these two groups, B or M, and for the KNN, will help us find the closest cells which are closer to each other, and then classify them into B or M. So the factors considered while choosing this data set, we have the data dictionary, the quality of the data set, the dimensions and measures, then the problem itself. So we consider the problem while choosing the data set was which couldn't choose a data set of a different problem, when we are doing breast cancer prediction. And then the quality of the data set. The data set itself is of a good quality. That's leading to better decisions due to the accurate data provided in the data set. Then the data dictionary, it has a metadata which provides good detailed information about the contents of the data set, such as the ID, the diagnosis, the radius, perimeter, etc. Continue. The important features in the data set, we have the BM, ID, number, radius, and then the texture. So the benign, as I explained before, the B indicates the absence of the cancerous cells. Then the malignant indicates the presence, and the ID number, which differentiates the patients. Then the radius, which is the mean of the distance from the center of points to the perimeter, and the texture, which is the standard deviation of the grayscale values. So we are going to the Bayesian theorem, which states that the conditional probability of an event based on occurrence of another event is equal to the likelihood of the second event given the first event multiplied by the probability of the first event. It describes, in other words, it describes the probability of an event based on prior knowledge for conditions that might be related to the event. Yeah. It allows unknown probabilities to be computed from known conditional probabilities based on the prior knowledge. So we need to have some knowledge. It is calculated as below. For instance, we have this example, you look through it in your free time. So the naive bias, it's a classification technique based on Bayes' theorem, which is an assumption of independence among features. This one works on an assumption that there is no dependence of other features. So every feature is independent on its own. The assumption is made of the features are independent, and the assumption made by naive bias is that each feature makes an independent equal contribution to the outcome. So now we are going to the Bayesian networks. So the Bayesian network is a compact, flexible, and interpretable presentation of a joint probability distribution. They are ideal for taking an event that occurred and predicting the likelihoodness that any one of the severe possible known causes was the contributing factor. So it is a probabilistic graphical model which represents a set of variables and their conditional dependencies using a directed cyclic graph. It uses a graph. For instance, it could represent the probabilistic relationship between diseases and symptoms. It provides a potentially useful tool for monographic decision support. So the difference between Bayesian theorem and naive bias. The Bayesian, as we've seen, the Bayesian theorem describes the probability of an event based on prior knowledge of the condition that may be related to the event, unlike the naive network, which works within an assumption of independence among the features. So I've provided a link down, you can go through more differences. And the difference between the what? Now this is the Bayesian network and the naive bias. Then the Bayesian networks show the joint probability distribution of events represented throughout the whole model, where naive bias is a simple model that describes a particular class in the Bayesian network. Thank you for listening. For references, you can look at this. Thank you. Bye.